Welcome back to the Law of Sines. Today we are going to look at some examples. The other video showed you the proof for both acute and obtuse triangles. Now we're going to look at the application of law of sines. And we will first introduce the concept of solving triangles, and then we shall use the law of sines for solving two cases of given for a triangle, angle side angle, and angle angle side. Now you may not know what that means, but we will explain it on the next page. Okay, so first of all, up until now, you've been dealing mostly with right triangles. And whenever you have a right triangle, there's two things that you normally use. Either Pythagorean theorem, if you're given two sides, or, let me see if this works. There you go. Make it nice and visible. Or you can use SOHCAHTOA. And let's see if this worked. Pretty close. Wow, even got the arrow. Okay. So that is only true for right triangles. Okay, you cannot use Pythagorean theorem, SOHCAHTOA for anything but right triangles. So we're quite limited on solving triangles. However, there is one thing in common. To solve any triangle, you need at least 3 out of the 6 parts. The 6 parts being 3 angles, 1, 2, 3, and or 3 sides, 1, 2, 3. So there's 6 parts to a triangle. You need any 3 of those parts to figure out the remaining 3 parts. Now, let me go ahead and erase those. Even with right triangles, we're always given 3 parts. The fact that it's a right triangle, okay, you're always given a right angle. And if I give you any 2 other things, 2 sides, 3 and 4, you automatically know the third side by the Pythagorean theorem. And now you could use inverse trig functions to figure out the remaining 2 angles, or at least one of the angles. Subtract, once you find that angle, let's say this angle is 32 degrees. Okay, well, the sum of all the angles have to add up to 180, or since this is 90, the sum of these two have to add up to 90. Okay, so you can figure out that final angle. So, when you are asked to solve a triangle, they have to give you 3 parts, and you must solve for the remaining 3 parts. Okay, I'm going to switch my screen here for a second. I missed. Okay. We are going to look at the 6 possible ways you could be given 3 out of the 6 parts. Okay. And I've set them up for you already. One way, though, is to give you all 3 sides. Okay, so what we mean by that is they'd have to give you values for these 3 sides. So they would have to tell you A is 12, B is 9, and C is 5. Okay? Or this next example shows they give you a side, an angle, and a side. So that acronym is side, angle, side. Okay, order doesn't matter or placement matters. In this case, angle is between the two sides, S and S, in our acronym. So the given angle must be between the two given sides. Then that would be side angle side. The next case would be given this angle, given this side, given this angle. So that acronym is, you guessed it, angle, side, angle. Okay, and again, the side, notice, is between the two angles. So it's the included side, or in the earlier case, we'd say B is the included angle. Okay, it's between the other two parts. Now this next one, if we just keep going in the same order we just did, left to right basically, counterclockwise, I'm given an angle, and a side. So we would call this angle, angle, side. Now, this is the first time where that's also equivalent to side, angle, angle. So it really doesn't matter which order we give it. Think about it. Angle, angle, side is the same as side, angle, angle. Okay, side, angle, angle would just be going clockwise. Okay, the first three that we did just happened to be the same thing forwards and backwards. ASA backwards is still ASA. SAS backwards is still SAS. SSS backwards is still SSS. So that's why I didn't write those. Okay, take those back off. Okay, so angle, angle, side's the first one where you could also say side, angle, angle. Okay, I'm pointing that out. There is a reason for that. And we're going to move down a little bit. The next one then, okay, this one I'm going to go counterclockwise again, but I am going to start at this side and then go side and then this angle. Okay, so that's three parts, two sides and an angle. One, two, the angle is the third part. Okay, we like to, in the civilized world, call that SSA and never reverse it. Because when you reverse it, it's could be considered a bad word. Okay, so please refer to it as SSA, not the other way. Now, that one actually is a special case. So it's kind of good that it spells a bad word backwards, because that'll help you remember which case is a special case. That will be the next lesson. Okay, and this last one is also a special case. Looking at the picture, we are given three parts: angle, angle, angle. Okay, but this one is special. So I'm going to put an asterisk next to that one, because we cannot solve this triangle. And hopefully you learned this in geometry. Anyone know why you can't solve this triangle? Don't be shy. Talk up. Well, oops. Let's take a look at this. I'm going to unlock it. I'm going to clone it. Clone. And I purposely waited until the video to show you this. Let me extend the page. Let me move this guy down here. Move this guy. Oops. Move this guy over here. Okay, we'll start it there. Okay, so you saw me clone it. I can lay one on top of the other. Perfect match. Okay, going back to the question, why can't we solve this one? What do you remember about two triangles that share the same three angles? I think I heard someone say it. They are similar triangles. And what did that mean? Well, basically, there's an infinite number of possibilities for the length of the sides. So for example, if I just take one of these two and I make it bigger, I believe we called that a dilation in geometry. If I line it back up over here, check it out. Angle C is exactly the same as it was as a small triangle. If I move this over, okay, line it up, angle B is exactly the same as the small triangle, and angle A is exactly the same. So the three angles are equivalent, but look, the sides could be this long, or they could be this long, or they can be anything in between. Okay, so it doesn't matter how big I make this, it could be this big. Okay, angle C still there, angle B still there, angle A still there. Okay, so it could be that big, 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 that big. Okay, it can be any size. So we cannot solve triangles given just three angles, so we need more info to solve. And obviously the only info they could give us is one of the sides. Notice once they give us a side, let's say they give us side B, well now I have the case angle side angle, or I could have, well that's good enough. Okay, so angle side angle. So I need some more information to solve. Okay, any questions so far? Raise your hand if you have a question.